Hello, and thank you so much for the invitation to talk to you today. I'm Winnie Courtene-Jones, a research fellow at the University of Plymouth in the UK. And I'd like to take this opportunity to present some of the results from an ocean voyage, eXXpedition round the world, which set out to study plastic pollution in our global ocean. So first of all, why should we study environmental plastic pollution? Well, research estimates that around 8 million tonnes of plastics enter our ocean annually. And since then, a more recent study has estimated that up to 23 million metric tonnes of plastics enters the aquatic environment each year. So that's into both marine and freshwater ecosystems. So it's evident that large quantities of plastics are coming largely from land-based sources and entering into our environment. So once in the ocean, currents and wind can transport plastics over large distances. Plastics are highly durable and pervasive, and research has shown that they can accumulate in certain areas. On the map, that's indicated by the darker red colours. So you can see enclosed seas like the Mediterranean, or close to the coastline where the inputs from land are the greatest. But also areas, remote areas, such as the oceanic gyres, these swirling bodies of water within the centres of our ocean, far from land. However, much of the ocean has not been sampled, and so the quantities of plastics and microplastics, the smaller pieces, so the quantities of these within the ocean are still largely unknown. But as our ocean is connected, and these plastics can travel such large distances, passing between ocean basins, this really presents challenges when trying to manage and deal with plastic waste, as often the plastic washing up on one country's shoreline may not necessarily have come from that country itself, really highlighting the need for international policies on waste management and plastic waste in particular to truly tackle this issue. So I'm now going to talk about eXXpedition, its mission, and what the methods that we used on board our vessel, and then share with you some of the results. So the aims of eXXpedition was really to generate a body of evidence about the quantities and types of plastics in our ocean, which would then go on to support evidence-based solutions. So eXXpedition set out on a circumnavigation of our planet to assess plastic pollution on their route. And you can see the route on your screens there. We were going to contribute towards evidence of the quantities and types of plastics in the environment. And as I said, support solutions of the most effective way to tackle this environmental pollutant. The mission was conducted on a sailing vessel, and it left the UK in October 2019. And the scientific investigation was led by the University of Plymouth. So the science programme on board at sea and on land was designed to advance a better understanding of plastics as a whole, but also work with key stakeholders such as industry to pinpoint solutions, and also with policymakers to address knowledge gaps and deliver evidence of the best solutions, the most effective solutions to reduce plastic pollution. As a majority of the plastics originate from land, this is a natural first step to begin our assessments. The Circularity Assessment Protocol was developed by Professor Jambeck and her team of waste management experts at the University of Georgia in the USA. And in each of the countries that we stopped at during the Round the World mission, we used this protocol to gather data on mismanaged waste, on litter and waste infrastructure. And this allows us to examine the spatial patterns of the most commonly littered items, and then use that evidence to make to give to local policymakers to inform their decisions about how they may reduce land-based plastic pollution. At sea, we conducted surface water man-to-tows. You can see a picture of the man-to-tow in the top right. And this skims across the ocean surface, filtering plastics in that large net coming out of the back of the tow. And this was used to examine the quantities and types of plastics within this upper part of the ocean. In the bottom right, you can see a sample that we collected in the Atlantic Ocean, a easily recognizable object, a piece of plastic cutlery, but contained within that small glass jar is a soup of very small fragments of microplastics. Not all of the plastics remain at the surface, but they can sink down through the water column. And so we collected subsurface water from a depth of 25 meters to understand the quantities and types of plastics distributed within this upper ocean. And then finally, to consider the last part of the marine environment, we used a grab sample to collect sediments to examine the abundance and polymer composition, making its way all the way from the surface through the water column and down to the seabed. So to assess the polymer composition, we used a PerkinElmer Spectrum 2 FTIR. And this we had on board the vessel with us. And it allowed for near real-time analysis of the polymers that we were identifying, which really helped start to identify the sources and the types of plastics. So what items these small anonymous microplastics may have come from. And this ultimately provides evidence for which sectors might be contributing and working with those to develop effective upstream solutions. Now, given that time is limited within this presentation, I'd like to just focus in on one particular area to share some results. So I'm going to focus in on our holistic study within the Southern Caribbean. And this used multidisciplinary approaches to gain a comprehensive understanding of plastic pollution within the Southern Caribbean, specifically starting our journey in Antigua, passing by and stopping in Bonaire, Aruba, past the coast of Colombia, and into our final port in Panama. And the work integrated marine sampling, as I've already given an overview, from the surface water, the subsurface water, and the sediment to look at microplastic pollution in these 3 different environmental areas. And we combined this with ocean modelling approaches, also terrestrial litter assessments and analysis of the regional policies and waste management, all combined to inform on the sources and the flows and the quantities of plastics within the Southern Caribbean. And now I'd just like to highlight some of the key findings from this work, which was published last year, and really emphasize the value of combining these multiple approaches, which examine multiple aspects of the environment to gain a much more thorough understanding of plastic pollution in the environment. So this figure shows the proportion of polymers, so the different types of plastics, identified in surface water within the exclusive economic zones of the 5 different countries that we sailed by. Overall, 18 different polymers were identified, and the polymer composition varied between the geographic regions. Overall, Antigua and Panama had the greatest diversity of plastics, so the greatest number of different polymers were identified within these 2 areas. Polyethylene, which is shown by the hatched bars, was ubiquitous across all of the areas, as was polystyrene, also known as styrofoam, which might come from packaging and consumer products. This is supported by the land-based assessment, which I'll talk more about a little bit later. And these found that food packaging and plastic fragments were consistently among the most prevalent litter types, indicating the contribution from consumer goods, which can flow from the land to the sea, and then the ability of these to fragment into microplastics, small pieces, when they enter the environment. I'd also like to draw your attention to the red bars, which is paint flakes, and these were identified in a number of the surface water samples. Next, if we look at the sediment, here we can see the abundance of plastic and its composition per gram of sediment. In contrast to the water samples, polypropylene dominated the sediment. That's shown by the pink bars. This polymer has applications in packaging, such as films and containers, and also in the maritime sector for its use in ropes. Now, marine plastics are considered to be a major threat to the sustainable use of marine and coastal resources in the Caribbean, on which the region relies really heavily upon for tourism and fishing. The data gathered in this study identifies that these industries might be contributing towards both the terrestrial litter and the microplastics that we identified in the marine samples. And this represents a really complex challenge when trying to manage plastic pollution, since both of these industries might contribute to plastic pollution, but are vital and valuable economies to the Caribbean region. Next, if we turn our attention to the land-based assessments. So here we can see the different categories of litter in each of the areas that we sampled. Most of the litter was dominated by food plastics and tobacco products, and also plastic fragments such as hard pieces of film were also found. And all of these items are linked to consumer goods. This matches what we found in the water samples, where I've already said that polyethylene, for example, was found in high quantities, as this is often found in film and multi-layer plastics associated with food packaging. The fragments that we found could suggest that weathering processes had happened, and these plastics might have been in the environment for quite a long period of time. So they might be fragmenting from larger plastics whilst on the land before becoming washed into the oceans. Just diving in a little bit deeper here, you can see the country and the top 5 litter items and the average density of litter that we categorized during our transacts. And overall, cigarette litter was the most numerous litter item in all of the countries apart from Antigua. As I've said, hard plastic fragments and food packaging were the most commonly identified in all of the countries, except Panama, which showed a slightly different pattern. Interestingly, Antigua was the only country that had plastic rope among its top items. Of the 4 countries that we examined, Panama has the highest estimated mismanaged waste. And it was interesting to see that the average litter density that we recorded was kind of an intermediate level between the different areas. There's now a great deal of activity in the Caribbean and implementation of legislation, including the Caribbean Waste Collective, which runs in Aruba, Bonaire and Curacao, and several national bans of single-use items have been implemented. If we use the data that we generated in our study, we can help to target we can help to evaluate the effectiveness of some of these bans, and also where countries may want to focus in implementing the next set of bans, or even behaviour changes and other interventions to reduce the plastic litter, which will ultimately then reduce the plastics going into the oceans. Now, just to highlight that we also carried out ocean transport modelling, and this was to assess where the plastics may have originated from. On your screen, you can see the results of a 60-day computer model, which shows where the plastics may have come from. So the triangles indicate the sampling areas where we collected surface water samples, and then the circular points show where that plastics may have come from in the 60 days before. So we're looking at the pathway of litter almost in reverse. And our results highlighted that the highest concentrations of plastics were identified around Panama. So that's shown by the green symbols. And the particle modelling shows that combined with the assessment of regional policies, indicates that much of the microplastics around Panama arose from a combination of transport via ocean currents and runoff from the mainland in Panama, which I've already mentioned has quite a high estimated level of mismanaged waste. In contrast, Antigua, which has a really high diversity of polymers, when we assess where those may have come from, we can see that the ocean modelling suggests that these plastics have been transported by ocean currents from the wider North Atlantic Ocean, potentially even originating from the so-called North Atlantic garbage patch. Therefore, combining the empirical data with this modelling approach, we can see that litter may come from a combination of local and distant sources, and the relative contribution of these will vary between the countries. And this is really important when we try and understand the transboundary movement of marine litter in the Caribbean or within any region. Because when we implement policies, we want to do so in a holistic and uniformed way so that we're actually reducing the plastic pollution, and the plastic isn't just washing up on our shoreline from another country carried by ocean currents. And this transboundary movement of plastics can undermine local policies aimed at reducing plastic pollution. And so just as I explained, these long distance transport means that even if a country is implementing waste litter policies, it doesn't necessarily mean that they're seeing a reduction in the litter on their own shoreline. There are now around 20 Caribbean nations which have some sort of legislation to reduce or ban plastics. And whilst we found really low levels of plastic bags or polystyrene items in countries where these bans were implemented, we were still finding these polymers and these items as microplastics that have broken down from the larger litter into these small fragments. So these were still present in the marine environment, even if the country adjacent had a ban against these items in place. And this really illustrates the need for collective efforts and policies to effectively tackle plastic pollution. So to conclude, a diverse range of polymers were identified. And this indicates that plastics arise from numerous different sources, really highlighting that the solutions also need to be diverse. Holistic approaches, combining land and marine sampling with modelling approaches, policy assessments, can really strengthen our understanding of the sources and the flows of plastics and inform where solutions may lie. Plastic is an international challenge, and it does demand international and interdisciplinary approaches to best tackle it. And the research also emphasises the need for these international strategies to effectively reduce plastic pollution, bringing together different sectors, community, industry, government, researchers, everyone. We need a seat at the table and to be involved to bring about change. If you would like to read more about the Caribbean study, there's information of the publication on your screen now. So with that, I'd really like to thank you for your attention. And I'd also like to thank so many of the people that made this work possible. So to the vessel crew, the shore team, and all of the guest crew on eXXpedition around the world. And of course, all the sponsors and supporters who enabled this work, including those shown on your screens. Again, I thank you so much for your attention today. And if you'd like to find out anything more about this work, about eXXpedition or any of the other plastic pollution research being undertaken at the University of Plymouth, there are links on your screen. Thank you very much.